Hi everyone, thanks for joining us on a Thursday evening. Hope you have had your dinner. If not, please eat while you're watching, I guess. That's the good thing about online events. And thanks again for joining us today with DataScience Singapore and also AI Singapore. We hope you are keeping safe and well wherever you are tuning in from. I'm Tjhi from the Google Developer Relations team. And before we begin today's session, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups from the region to learn and connect with one another. So we have a space in the Google Singapore office that sadly, for the past, I think 1.5 years, hasn't really been in use. But here's to hoping everything opens up real soon and we can all get back to physical events that everybody misses. So we are really excited for today's speakers who's gonna be talking about newly launched open source tools. And without further ado, I'll hand the stage over to Rizal from DataScience Singapore to share more about today's session with us.
Yeah, thank you very much, Justin. Yeah, hope you're doing well. I hope everyone is doing well. So thanks. And hello to everyone who's tuning in, even if you're eating dinner. All right. So I'm Rizal from DSSG, one of the organizing committee members. So just to give a quick introduction of what DSSG does, right? DataScience SG. What we do is that we organize events, mostly on a monthly basis. Where we organize. We get speakers who will share on interesting topics with regards to data science, AI, and whatever the audience will wish to know more about this field of work. And for today, not long from our previous session. All right, today we are lucky to have AI Singapore. Right, they're a huge national program. Later, my friends at AISG will talk more about it. And today they'll be talking about the open source tools that they have released recently. And there's so much to look forward to. All right, so I will bring the first speaker, William, on board to give an introduction of what AI Singapore is and the context of where do these open source tools come from. All right, so Justin, shall we?
Yep, let's do it.
Good evening, everyone, and thank you so much for your time with us tonight. My name is William, and I am one of the heads, one of the heads of AI in AI Singapore. And today we are going to introduce 2 new open source tools. The first one is on natural language processing. We call it SGNLP. And the second one is on computer vision, and we call it PeekingDuck. I have my colleagues with me today, Alan and Jonathan, who will share with you the potential values of SGNLP to those of us who are dealing with natural language. And then later on, Li Ping will demonstrate to us how PeekingDuck can make our life as computer vision practitioners easier, right? But before we jump into the tools, allow me to set the context by quickly introduce you to AI Singapore. Now, AI Singapore is a national AI program. We were launched back in June 2017. We are funded by the NRF, and our mandate, in a nutshell, is to help Singapore build a healthy AI ecosystem. Right? And we do so by engaging in various activities that can be categorized into the 4 pillars that you can see on the slide here. Now, the first pillar is AI research, where we conduct basic research in collaboration with professors, scientists in local universities and research institutes. And I think the goal really is to ensure that Singapore remain very relevant in the global landscape of AI competition. The second pillar is AI technology, where we address national level AI challenge, the likes of those that are described in our national AI strategy, which I'm sure many of you have read the document. And we do so by working closely with consortia of industry, government, and academia through various thematic challenges, grant challenges, and other applied research activities. The newest pillar is AI governance, in which we look at the 3 key questions related to the ethics of AI and whether or not our AI models are trustworthy. And the last pillar is where the team that is presenting to you today is from. It's called the AI Innovation and Makerspace pillar. Our mandate is very simple. It sounds simple, but it's not simple, right? But it's pretty clear. We need to promote the adoption of AI among local businesses and local organizations. And to do so, we engage industry players in relatively short-term AI industry research projects under the program called 100 Experiments. In 100 Experiments, we provide co-funding to industry players to the tune of about $180,000 to $250,000. But we don't just provide funding, right? Our team actually work with you in the span of 9 to 18 months to build AI minimum viable products. It's called 100 Experiments because we're supposed to deliver at least 100 of such short-term projects. The current goal has been, I think, double or triple, right? But we are at 70 right now, around 70. And as we work closely with the industry players, we perform mapping of some of the recurring AI needs industry face, right? And if we sense any market gap, we try as much as we can to abstract those needs and build open source tools to address those needs, right? So that next time somebody else comes to us with similar problems, at least we can refer them to those open source tools, and hopefully that will help them, right? And the activity of building these open source tools is what the term makerspace in our division name primarily refers to, right? And I think this is also the right time for me to switch back to our main topics of today, because SGNLP and PeekingDuck are 2 of our makerspace products. SGNLP is by nature an aggregator. We consolidate Singapore-built NLP models that are scattered in many places into one place, right? We package them nicely so that it becomes very accessible to all of us here. Whereas PeekingDuck is a new computer vision framework that will simplify and reduce the time to develop new computer vision module. With that, I would like now to hand over the presentation to my colleague Alon, who will walk you through the detail of SGNLP. Over to you, Alon.
Thank you, William. Thank you, William, for the introduction. My name is Alon, and I'm part of NLP Hub and the team in AI Singapore that is in charge of building such open source tools in the NLP area. So today, as mentioned, I'm gonna introduce to you the new platform from NLP Hub, which is SGNLP. We launched it at the beginning of the month. And I'm gonna share with you, or at least our plan for today would be that I'll start by sharing a bit about the background. Why did we even build the platform? Why do we think it's useful? Introduce the platform to you. We'll have a short demo, go through the website, see how actually you can use the platform. Then we'll share a bit about how we envision the product being used, go through a couple of use cases, and I'll hand over to our lead engineer, Jonathan, to share a bit about our development journey and some technical challenges that we faced along the way and how we dealt with those. And that will be it for our part. So without further ado, I'll dive right into the background. So to whoever of you are dealing with NLP problems, you know that usually those are not straightforward problems. We generally didn't yet to find an algorithm that can solve all problems in the world, but specifically also in NLP domain, problems tend to be more specific and require customization for any application that is being used. And even given that, we're still living in a relatively fortunate time that we can leverage open source tools such as Spacey, Hugging Face, LNLP, and the models are being shared among all practitioners for us to use, and allow us to focus more on the implementation and the application for our problem, experimenting with them, rather than worrying about if we implemented the paper correctly, or if we did, and if we understood the concepts. Ideally, also, but not everything is implemented through those tools. And a lot of times we go to the literature and read papers from this domain. And ideally, each paper would come with an API that we can directly use. But more often than not, this is not the case. And we do have to build sometimes things from scratch. In a way, this is where we come in, and we aim to bridge this gap, help bring cutting edge papers, research, models, and make them more accessible to the public. And we do so because we are in a position as AI Singapore to locate those gaps in the industry and try to bridge them and help the industry to use more NLP tools, more NLP models, and to leverage the technology to create better businesses. And then why do we think this is a good idea to do? And specifically, why do we think it's a good idea to do in Singapore? So as AI Singapore, admittedly, we have interest to promote local NLP research and translational research. But having said that, we are coming into a domain that is already rich in NLP research. We have strong universities and prominent researchers that are publishing every year in top conferences. And you can see here in the world, it's a very high place, or high ranking, sharing, publishing every year. But the problem is not all of those models are getting enough attention and are being able to put into use. And again, this is the gap that we are aiming to solve or to bridge. And as we also envision that as the space becomes more tech savvy and people are using AI technology more and more often, there will be a need for a place for people to come, collaborate, share what solution they have in local context. And we aim to build this platform for people to contribute from all, both the research community and from the industry, and sort of a place for everyone to share and collaborate. And we'll show you exactly how we envision that to happen. But this is generally the idea behind AI Singapore, and this is how we started. And without further ado, we'll just I'll share about the platform. So all the ideas and the background that I shared, we distilled into a vision, which is to make models from Singapore NLP research groups more accessible to practitioners and to the industry. And we hope this will lead to a closer collaboration and more opportunities for translational research. Basically, either by using the models that from the research community that we publish through our open source platform, or by striking a collaboration between the researchers and whoever was exposed to that model through our website. Next up, I'm going to share with you our interactive demo website where we share the models. So this is the website. Here we have our intro and some legal information and a way to contact us if necessary. And on the left side, we see different categories for NLP problems. And under each category, we have the models that we implemented from different researchers in Singapore. You can go through the models later and each use case and try it out for yourself. For now, I'll just run through a short example. So this is the model, a short explanation about what it does. We have some example input, but you can basically put here anything that you're interested to test the model on, and then you run the model. This model is quite straightforward. It's taking a text. This is running live, of course, so whatever example you could put in, it executes on that. And it gives the original form of the sentence on the left side and the corrected ones on the right. If you wish to learn more about model and understand more about it, then we have the model card tab, where you can find the paper, some basic information about the model, what is the input, output, what is it supposed to do, a use case, and a way to contact us at AI Singapore or get to the source code where we took the code from. Of course, it's all coordinated with researchers. If you want to learn more about how to get in touch with us, so first we have on the right side, we have a discussion forum. So if you have any questions, queries, some topics you want to discuss on NLP, you can bring it up there. Visit our website where you can see other products that we're bringing to light. And of course, the documentation, which looks like so. So this is the welcome page. And if you wish to have a quick start and see how to use a specific model in a very simple way, how to install the package, it gives you that information. And when I refer to the package, it's actually a Python package that you can load, use, and train all available models on SGNLP. And it looks like that. There's also a link here to the documentation if you wish to learn anything more about that. And lastly, I would say that this is, of course, we plan to still grow this platform. Currently, we have 4 categories. In the next couple of months, we plan this to be doubled. And in future, we hope the community will also be contributing. Research groups will also be contributing. And this will become a place for people to share ideas about NLP and NLP models for the community to use. Okay. And now I'll move into the use cases part, where I'll share 2 use cases on how we envision the product is being used. First is about optimizing customer service. And the scenario is if you're a company that's launching a new product, and in this case, you want to get quick feedback from your customers. If there's feedback or negative feedback, you want to correct this thing, implement any new features. So you want to get it fast, and you want to get specifically the one that triggered specific emotions for your customers. Or alternatively, if you're managing customer service, then a live chat, a call center, or actually you're training such customer service agents, then you also are interested in specific to find the insights or the parts in the text that give you most information that you can tackle. The challenges, as it happens so often, is that you have limited resources. It's either yourself or you have a small team handling that, or you're in charge of training. And when reviews or feedback is piling up, this is very difficult to scale if you do it manually. So, of course, as in anything, we wish to automate. And in this case, we suggest automating recognizing the cause behind specific emotions in conversations or text. And to do so, you can use one of our models, which is the emotion entailment one. So for conversational tools, under the category of conversational tools, there is emotion entailment. And if we go here, you can find two models, one for emotion entailment, one for the span. Again, you choose the model. If there are a few, you can choose an example or input yourself. Here is in a conversation between A and B person, and you run the model. And the results will be shown here again. The target utterance is the last one, and currently it's limited to anger, but the paper itself doesn't limit it to anger, and we'll be opening the other emotions as well. And for your specifically here, it's about a road scenario, and the reason that someone is angry can be found like, you didn't give me enough time to change lanes. Specifically, other examples can be that this one will be in our demo as well. In this case, it's not anger, it's sadness, and you're really it's a real letdown. And why is that? Because my girlfriend's speaking ill of me. And in the scenario of a random Amazon product review that we got online, if you input it into the model, then you're angry about a specific product, and it gives you a possible utterance that shows why are you angry about this model, what is the cause behind that, helping to automate and maybe extract the parts of the text that you were most interested in and speeding up the process. And now you want to use it. In that case, you'll go back here, and under the model usage tab, you can find the code that you need in order to run this on your side. You can train it, of course, on your own data, customize it. And we try to make it as simple as possible with a short example here in case you want to run this toy example. And if you need more information, so on our documentation, there are advanced tutorial where you can find two of the models and a more elaborated use case on example on how to use this, explaining every part of the implementation. Yeah. So as we saw, the model usage tab and the documentation for those two. I'll quickly run through a second scenario, which is legal documentation analysis. So if you're, in this case, you're working in a law firm, frequently faced with the challenge to either extract information regarding specific entities that are repeating in long texts, or are you trying to find precedents for various cases or scenarios? And again, you have a deadline by the end of the week, and you have limited resources, and the scale or the number of documents you have to go through is really big, and you wish to automate this one. So for this case, one possible models or two models actually that can help you speed up the process could be the relation extraction and the core reference resolution one. This is actually a two-stage solution. One deals with core reference. It's under the knowledge mining category and relation extraction. The first part finds core reference named entities, which means that if a specific entity is mentioned in the text multiple times, so that model helps you tag those entities, either a person or a place or a company, and gives them number. And whenever you hover over one, the others will be highlighted as well, even if it's not all in the same form. It's a full name, can be only the first or last name of the person, and it helps speed up the process to find all the mentions of that entity. And the second part is the extracted relations. So here is where you reside, your date of birth, but this, of course, can be other relations. There are more relationships mentioned or implemented in the paper. But in this case, you need help because, for instance, there are relationships that you're looking for, like company being merged or bought, and those are not implemented in the original paper, and you need more. So in this case, again, if we go back and we see under knowledge mining the relation extraction, and this is not enough. So of course, if you're in the field and you understand and want to learn more, you can find the paper, go in, read the paper, understand more about how it's implemented and how you can take it one step further. Alternatively, you can contact us or you can contact the research group. The information is usually within the paper, or you can contact us. The information to contact us is either here or at the bottom of every page on the platform. And we can either strike a collaboration between you, the company, and AI Singapore, help you implement a model for your specific use case, or you can strike a collaboration with the research group that did this work and ask them to elaborate more to build a specific solution for your use case. So this is like an example for the information about how to, in the top of a paper, how to reach out to the research group, and this is how to work with us. And of course, as we mentioned before, you can reach out in the community forum and with any question about related to NLP, and we'll be happy to help you through there. Yeah, and I will move, give the speaking to Jonathan, my colleague, which was leading the development of the product, to share a bit about technical challenges along the way.
Hey, thanks, Alon. So I'll now do the technical sharing for the project. So this section of the talk goes in depth into the technical details of our work. So for those of you who are actively involved in the development of ML applications, you might find this part relevant and interesting to your work. So I'll be covering how we went about our Python package design, tech stack we used, the architecture of the application, how we managed our deployment, and general development experiences. So one of our first tasks was to decide on how we want our open source Python package to look like. So we believe in the KISS principle, which is to keep it simple. So we don't want to create another framework for folks to pick up. So we looked into a few of the popular NLP libraries such as LNNLP and Hugging Face for inspiration. So ultimately, we went with the decision of using the interfaces from Hugging Face's Transformers package. So some of the reasons include that it is a light wrapper around PyTorch and TensorFlow, not very highly opinionated, so very customizable. It is already quite popular among the NLP community, and it has a very nice and simple interface with helpful utilities. So next, another big part of our work is to convert some research papers code to fit into the package. So one of the challenges is that research code is often written with a slightly different intention. So the aim could be to get an improvement in a certain metric. So sometimes it leads to the model not being ready to be used in a general sense. So it could be like pre-processing and model steps not being very clearly separated. So training and model configs are tangled together, and it might be difficult to save and load easily as well. And of course, each researcher has a different coding style. So for someone who wants to get into using this, some of the researchers' code, it can be like there's a steep learning curve to it, and you might be deterred from doing so. So what we want to do is to refactor this code and unify the way it is being presented. So of course, our the design is heavily influenced by the transformers package, as I earlier mentioned. And we also do our best to reproduce the results that are reported and indicate the results of the models that we train in the model card section of the demo page. So now let's take a quick look at some of the key classes and interface we have in the package. So during training, we have things like the training config. So this should include like parameters on how a model is trained, such as learning rates, batch sizes, epochs. We have model config. So this is where which is used to construct the PyTorch model. So we should keep information that concerns the model, such as layer sizes, types of layers, or activation functions. And then we also have the preprocessor. So it's just something that will take the data in its original form or whatever form it was in the data set and returns a tensor dictionary. So things like tokenization and other forms of preprocessing happens here. And then the model should be able to take that and then return an output. And all these things require some form of state that needs to be saved so that they can be later loaded again for inference. So all these classes and objects have some method to for you to use to easily save and load them. Now, of course, later during inference, we will not require the training config anymore, but saving it is still useful. So we know how the model is trained, and ideally we want to be able to reproduce the same results with the same training config. So then for inference, sometimes we have an extra post-processing step. So this is an optional class. Some models are complicated and can't be easily interpreted, whereas in some cases they can be, such as a simple binary classification problem. So in the cases where it is hard to interpret, we recommend adding a post-processor to change it to a more understandable form. So, but even then, it can still be complex and difficult to understand, and this is where the demo website comes in. So the demos are designed to be visual and help users easily understand what the model actually does. So let me cover how the architecture works, so how this web application is done. So we deploy on a Kubernetes cluster. So there is a single entry point through the ingress, and depending on the route, you redirect it to different services, such as the UI or the APIs. So this is also known as a reverse proxy setup. So what happens here is that we treat every model as a separate service, and we can scale the number of pods running if we want to fulfill a higher load demand. So now I'll cover the tech stack that we used. So we use React and TypeScript for our front end. So this is a typical front end tech stack. So though we did start with JavaScript, and we felt that using TypeScript was actually helpful in organizing and understanding the code. The backend is something relatively simple. We use Flask for the backend APIs and gUnicorn to run the server in production. And we have our SGNLP package, which makes use of PyTorch and transformers to load and run the models. Another big part of our project is how we handle deployments. We make use of GitLab CI/CD to run tests, build our Docker images, push them to registries, and deploy them to the cluster using Kubernetes cluster using Helm. And we also have the Azure Blob Storage, where we host our weights and configuration files that are available for the public to download. So yeah. So in the following section, I'll cover the points that I felt were important during development. So first of all is to make deployment easy. So we only built all our pipelines for our model APIs in the second half of the project. And before that, there was actually a lot of pain and time involved for individual developers to try to build and test locally. And so having the pipelines for the model API being ready improved the development feedback cycle. So our CI/CD steps are fairly straightforward. So we run tests to check if there are breaking changes, build the images and push them to the registry. and we run the Helm upgrade command to apply changes to our deployed environment. So we also make use of multiple deployment environments. We have a staging environment, which is available to the dev team to test changes. We encourage devs to use it for their own testing. Then we have the production environment, which is a stable environment that we only deploy to after testing on staging. And then another question we had was whether to go with Flask. So ultimately, we went with it for its simplicity, but there are many question marks on whether it can deal with scalability issues. But we decided to solve it through the Kubernetes configuration, so like what I mentioned earlier. Yeah. So of course, there are also other model serving options that we'll briefly discuss soon. So some of the benefits of Kubernetes is that we are able to easily scale the deployments if needed. Also, there are no downtime during deployments if properly configured. So yeah, and if we want to use a more advanced model serving framework, they typically have integration with Kubernetes cluster. So things such as Seldon, KF serving, Rayserve, they're all model serving options that can handle much higher loads. But for our current load, demand and load, Flask together with Kubernetes is sufficient. So another challenge we had is having many models to deploy. So here's an image of how some of our model pipelines look like in the GitLab CI. So to effectively manage the deployment process, we make heavy use of templating tools such as JSONnet and Helm. So the use of such templating tools let us reduce the duplication of code and configuration, and we can more easily manage it across the various environments that we are deploying to, such as in staging and production. Yeah, so that brings me to the end of the technical sharing. Now I'll hand the time back to Alon, who will conclude the presentation.
Thank you, Jonathan. I'll take this opportunity to thank the team that worked and developed this platform and still does. So as I mentioned, Jonathan led the process. Benedict, which helped Jonathan in leading the development, is currently answering some of the questions that you guys are asking. And Raymond and Jechong, that I hope are watching us today as well. We're also part of the AIP program of AI Singapore and worked on this platform. As I mentioned, we continue to develop it. And so I understand also in my previous, when I showed the demo site, the text might have been a bit small on your screens. So I hope this gives you extra motivation to go and visit our platform. The address, the link is here, and we'll share it later in the comments as well. I also want to invite whoever might be interested to work on such problems in machine learning generally and NLP specifically to apply, because we are hiring and recruiting more for our growing team. We'll be actually launching another NLP product in the coming months dealing with Southeast Asian languages. So stay tuned for, if you want, you can subscribe to one of our channels and hear more about it. And lastly, if you guys your interest is strictly in NLP and you have questions right now, you can do it in the comments, and we'll answering questions in the comments throughout the session as we've been doing. And there's also a live Q&A at the end of the session after the presentation from CV Hub and about PeekingDuck. And without further ado, I'll pass it on to my colleague Li Ping to share about that awesome computer vision tools that they developed.
Hello, everyone. So now we switch gears from NLP to computer vision or CV. So my name is Li Ping, and I lead the Computer Vision Hub in AI Singapore. And today I'm very excited to share about PeekingDuck. And this should take about half an hour. I'll start with an overview and some demos, explain how it works, how you can use it, and even customize it for your own project. So why did we create this thing called PeekingDuck? Well, we've worked on many CV projects for industry, and what we found is that while the types of CV problems are very varied, many of these projects actually share repeated code, such as reading from a video or an image. And in some projects, even a pre-trained computer vision model for object detection or pose estimation can be reused. So we got tired of rewriting our pipelines, and we decided to build this PeekingDuck framework to cut down development time for future projects. Raisa, maybe you could share my screen now. Thanks. Okay, so let's find out more about PeekingDuck. So you can find PeekingDuck quite easily. Just go to Google and look for PeekingDuck GitHub. And it should be the one under the AI Makerspace GitHub repository. And the PeekingDuck is a double E instead of a single E. So why do we call it PeekingDuck? Well, if it's a single E, then it sounds like a restaurant dish, so it's easy for you to remember. But there's actually a deeper meaning behind this. The name PeekingDuck is actually a play on two words, peeking, because we deal with computer vision, and duck in duck typing, because we're using Python, which is a dynamically typed language, and that's called duck typing sometimes. And this is our PeekingDuck logo, which we think is pretty cute. So right now we have tested PeekingDuck on 3 Python versions, Python 3.6, 3.7, and 3.8. And we have also tested it on 3 operating systems, Mac OS, Windows 10, and Linux. And most importantly, PeekingDuck is under the open source and permissive Apache 2.0 license, which basically means that you can download it and you can do whatever you want with it. And without further ado, let's go to the first demo. So the first step over here would be to install PeekingDuck, which I have already done. So I will skip that and go on to the second step over here, which would be to create a project folder. So tonight is DataScience SG, right? So I'm going to make a folder called DSSG. I will go into it. And there's this special command called PeekingDuck init. Maybe I'll just zoom in a bit more. PeekingDuck init, which will initialize an empty project. So I will just run that. Right, so you can see that it has created a folder, and let's just open it up. Under desktop, under DSSG. So we have 2 new files here. One is a run_config.yaml file, and another is a source folder. I will talk more about these 2 later on. Right, so the next step, actually, you can run the demo immediately. So I will go ahead and run the command PeekingDuck run. The first time we do this, it might take a bit longer because we need to download the model weights. But I've done that previously, so it's much faster. Right, so you can see that this demo is running live right now. What you are seeing actually is object detection, where the CV model, it detects me, a human object, and it predicts my location. And you can see the yellow bounding box or the rectangle around me actually moves along with me. And yep, so this is basically the first demo. And if you have a webcam, once you download PeekingDuck, you can run this almost immediately, like what I've done. So next, I will explain a bit about how PeekingDuck works. And there are 2 important concepts that you need to know. The first, right, is this thing called nodes. So nodes are the building blocks of PeekingDuck. And there are 5 kinds of nodes in PeekingDuck. The first is the first 2 are the input and the output nodes. And the input nodes basically deal with different inputs like videos or images. And the output nodes deal with tasks like showing the results on the screen or saving it out. And there is also a model node, which is basically our bread and butter, the AI model, the computer vision model. And there's also the draw category, which is responsible for drawing the results. And last of all, there's this special category called Dabble, which I will talk about more later on. So notes are the first thing you need to remember. The second thing that you need to remember is pipeline. So pipeline is basically a chain of different nodes combined together. And in the demonstration just now, right, which I will maybe just open up on the side, it's still running. So it's actually, this demo is made up of 4 nodes combined into one pipeline. So the first node is the input.live node, which reads from my webcam, and it produces this image frame called IMG. And this IMG goes into a data pool. And the next node in line is a model.yolo node. This is the object detector, the CV model. It takes in the image frame and it makes a prediction of the bounding box of where I am and also the label. In this case, I'm a human. Next, it goes to the third node, which is a draw.bbox node, which takes in all of this and basically just draws this yellow rectangle around me. And the final node would be the output.screen node, which is responsible for showing it on the screen so that all of us can see it right now. So I'm going to end this demo right now. Right, so I think you have an understanding of how nodes come together into a pipeline now. So I will revisit this node category called Dabble. Our CV model node, it does the heavy lifting. And the Dabble node is just something that, it does something a bit more with the result. And you can see in the description here, we wrote that Dabble nodes are methods that dabble with model predictions to produce useful results. There's another reason why we call it Dabble node. And if you, let's look at one image here. So this is actually a duck that is dabbling. And when it's doing this, right, it's actually poking its head under the water to look for food. So this is another reason why we call it Dabble. And now that you know about nodes and pipelines, let's move on to the next section, which is how to change PeekingDuck nodes. So if you go to our GitHub and scroll down to this section, you'll be able to see most of the documentation for PeekingDuck is actually at our Read the Doc site, which I will go into right now. Right, so just to orientate you guys, this is our Read the Docs page. There are different sections on the pane on the left. There's an introduction section. There's a getting started section, which we'll run through more later on. There's a section on the different CV models that we have. There's a section on the use cases, and finally, there's a section on API documentation, which we will go through very soon. So let's see. Okay, as a recap, now just now we ran this special command called PeekingDuck init, right? And just to refresh ourselves, when we ran that command, 2 different things were created: this configuration file and a source folder. So let's go into this configuration now. I'm opening up on my Visual Studio Code. And yeah, you can see that actually all the 4 different nodes that we use in the demo are shown over here. And now I will show you how you can change it. So instead of object detection, I want to try pose estimation. So I'll use our PostNet human pose estimation model. And now instead of drawing a bounding box, I will draw poses, key points. And let me run it again. Right, so something different is happening now. You can see that this is not a bounding box, but it's a human pose estimation. So basically, the AI model can detect my eyes, my nose, my ears, my shoulders, elbows, wrists, hips. I can't show you my legs, but you get the idea. And I'm going to quit this demo. And I just want to illustrate, basically this example really shows how easy it is to use PeekingDuck, because simply just by changing 2 words from YOLO to PostNet, from bbox to poses, I've switched the task completely from object detection and human pose estimation. And the next thing I want to show you is how to deal with saved videos. In the last 2 demos, we were running a live demo using the input.live node, and it was basically reading from my webcam. But now I want to work with a saved video, and one that I would like to use is this one. So it's a short 5-second clip of two ducks walking around. As you can see, we really like this duck theme. And yeah, let me just move it into a folder. Right. So in order to know what notes you want to use, okay, maybe I'll explain a bit more as well. So the task that I want to do, right, is to work on this video where I want to detect these two ducks as objects and draw the rectangular boxes around them, and also save the resulting video. So in order to know which nodes I need to use, I need to go to the API documentation in our Read the Docs page at the bottom left. And let's go to input first. And just now we were using input live, right? Now we need to use input.recorded because it's the node that's responsible for reading from a directory. So let's click on this node. Yeah, so for every single node, basically, we are going to describe what inputs it takes, what outputs it gives out, and also the configuration for that node. So in this case, I think I can go with the default configurations. The only thing I need to change is the input directory because I have moved it to a certain folder. So let's go back to here. Instead of live, it's going to be recorded. And I will change it to input directory. And hopefully I remember this correctly on my desktop and under input. Okay. The next thing that I want to do is to change this node. So it's a duck, so there's no human pose estimation. So I'll change it back to the YOLO node and a few other things I need to change. So let's go back to Read the Docs. And now the right section will be under model, where you can see right now we only have 4 models, 2 for object detection and 2 for pose estimation. But over the next few months and the next few years, we are going to add more and more to our model zoo. So let's go into YOLO mode. And yeah, you can look, you can see that right now our YOLO node is capable of detecting objects from 80 categories. So you can actually change the category by clicking on this. And this is basically a table of the different categories of our models. And looking at the YOLO category, just now it was detecting me as a person, so it was category 0. But now we want to detect ducks, which I guess is a bird. So we'll change it to category 14, 1-4. And we also need to know where we want to change, how we want to change that. So that would be under this configuration called detect IDs. So I will just go back to this and change it to detect IDs 14. Okay, then the next one, no human pose estimation. I just want a bounding box, so I will just change it to B-box. And for the very last one, which is the output node, I will change it to, let's see, under output, we have a CSV writer, which is not what we want. Output.screen was for showing on screen, which we did already. I want to save it to files, so I should be using media writer. And the only configuration that I need to change is basically the output directory, where I want to save the file. So let's go back to Visual Studio Code and change it to media writer. And my output directory would be also on my desktop, but this time I will save it to a folder called output. Okay, so if I have keyed in everything correctly, it should run without errors. Let me just clear the screen and run it again. Right, so it's actually running on the video now, and you can see that it shows the progress over time. So when it reaches 90 or 100%, then we know we are done. Almost there. Maybe I'll just open up the output folder. Okay, you can see that it has finished running over here. So let's see output folder. And we see that now there is a video here. And yes, the object detection model does manage to detect these two ducks. Okay, good. So one other thing we can try for fun is to try working on another image. So let's try it on a real Peking duck. Do you think the model would be able to detect this as a duck? Let's find out. So I will move this into the input folder. Yep, that's the only file inside. Let me just clear this and run it again. Right, so this time is very fast because it's just one image, so one frame compared to a video with many frames. And if we go back to the output folder, okay, nothing was detected, which I guess it means that a roast duck is not the same as a live duck in the eyes of our model. And this basically covers how you can change nodes and node settings. Now, I have a question here. What happens if you change this from draw.bounding box to draw.poses? Will there be an error? Let's find out right away. I'll just run it again. Okay, it looks like there was an error, right? It says that the nodes in this pipeline do not form a proper channel. And the reason why is because this draw.poses nodes, this is for drawing the key points and the edges of my eyes, my nose, and all these different positions. So it requires key points and key point connections. But the AI model used in this case is not a human pose estimation model, it's an object detector. So it produces stuff like VBox and VBox labels, but not what the draw.poses node requires. So as a result of that, it doesn't work. So we implement this check at the beginning just to make sure that the nodes that you are using are the right ones. And I guess we can always come back to this diagram and visualize and think, oh, this is how all the different nodes come together in the pipeline. And the inputs of one node needs to be the outputs of another. For more information on what kind of inputs and outputs are required, you can simply come to our API documentation here, and you will be able to see the inputs, outputs, and the configs of each node. Okay, so I think now you've seen gotten a quite good understanding of what PeekingDuck can do. Let me show you other additional features. The first one I want to show you is building custom nodes. So in some cases, you may need to create your own custom nodes. For example, sometimes you may want to take a snapshot of a video frame, like people fighting, for example, and then post it to your API endpoint. Or in another scenario, maybe you have a model that is trained on a custom data set. For example, something that has been trained to detect license plates, right? And you would like to use your model with our PeekingDuck's input, draw, and output nodes. So we made PeekingDuck very flexible such that you can combine your nodes with our nodes. And I won't go through all the details here, but at a very high level, what you need to do is to create a script, a Python script for your node which has an init and a run function. That's number one. Number two, you need to create your own configuration file with the input, the output, and any special configurations. And number three, once you've done that, just add your custom node to our run config file and run it. And that's basically all you need to do. The second additional feature that we have for PeekingDuck is what we call our Python API. So in some cases, you already have a project where you have an existing code base, but you might want to use PeekingDuck because of some of our features or nodes. So what you can actually do is to import PeekingDuck into your Python code. As you can see in this example over here, where you can import PeekingDuck and use different nodes to extract whatever you want out of it. And this is just a snippet, but we also have example here. You can even use PeekingDuck with Jupyter Notebook, or in this case, we have this demonstration on Google Colab that you can try as well. Yeah, so it's pretty straightforward, and all the instructions are over here. The next thing I want to cover is what we call use cases. So let's go back to introduction. And these are what we call use cases, where basically my group in AI Singapore, we are interested to use computer vision to solve real world problems. And that is why we have created these use cases for PeekingDuck, which are basically a special combination of nodes to tackle specific problems. And perhaps the best way to show this is to give you a quick demo again. And this will be the last demo for tonight. So let's try this thing called zone counting. Yeah, so each of the use cases, we have described how it works and how you can use it, but no time to go through. So I will just demonstrate it to you by copying the config file for that and pasting it over here. And just a note, you can see that this use case, right, there's a lot more nodes compared to the previous demo, right? You have a double node and a zone count node and a few other things. So I'll just clear my screen and run it again. Right, so this time around, we are doing what's called zone counting, where, okay, if you take a look at below me in the box, there's this little dot, right? And on the bottom left, there's a legend which says zone 1 and zone 2. So zone 1 is this area bounded by the cyan or turquoise box rectangle, and zone 2 is the one bounded by this dark orange or red box. So right now it says that there's one person in zone 1, that's me. But if I start moving over to the other side, then I go to zone 2. And if you have a lot more friends and they all come in here, you can see basically it will just keep adding the numbers in the right zones. So basically I just define the zones over here. And in this case, I just define two very simple rectangles. But you can actually change this to be a triangle or a pentagon or hexagon or even more and more sides, right? So for we think that this will be useful for certain scenarios, like for example, you want to detect how many people are waiting at the bus stop, for example. So if the bus stop is over here, you just draw a shape around the bus stop, and then the object detection model, it will just detect the number of people within the bus stop. If people are walking outside the bus stop, it will not detect it. And yeah, so this has many applications in, like, for example, retail analytics or checking if certain areas are very crowded. And that is one example of a use case. Now I'm going to show you other use cases very briefly. The first one is probably the one that we are most well known for, social distancing, where we use human pose estimation and we estimate the distance between two individuals. And if they are too close, we will say that they're too close. So this was something that we deployed for HP Singapore last year in their production plant. And yeah, so that's another use case. A further use case would be an extension of that, where instead of just detecting the distance between individuals, we also check to make sure that we check whether they are in the same group. And this is quite useful for sometimes the government regulations, 2 people per group, sometimes it's 5, sometimes it's 8. So we can just adjust this accordingly. So these two use cases are what we developed to try to support the fight against COVID-19. And the last one over here is object counting, which is a much simpler version of the zone counting, which I showed you, where there are no zones and it just counts the number of objects, which can include like humans, cars, motorcycles, animals on the screen. Yeah. And right now we only have 4 use cases, but we will be adding more nodes and use cases over time. So I'm wrapping up this presentation. Just want to say that my team at AI Singapore, we are committed to maintaining PeekingDuck and continue to keep it open source and improve it over the years. As you have seen, one of the main strengths of PeekingDuck is its modular node system. And with this, PeekingDuck is actually scalable. And we are able to add more nodes and better nodes over time. So stay tuned for our latest developments. In fact, I think most likely we will do another release of new nodes and use cases by November this year. And also, as you know, there are many developments in the field of CV. Most recently, those of you who are following, there's vision transformers, and there's also NLP mixers. both of which are not using the typical convolutional neural network or CNN architecture. And we are constantly surveying the scene, and we will add new models when the time is right. In the meantime, we encourage you to try to use PeekingDuck, to install it, and start our repository over here on the top right. And if you like it, recommend it to your friends and colleagues as well. You are also welcome to join discussions about using PeekingDuck either in our GitHub discussion board or AI Singapore's community forum. And last of all, to conclude, we have benefited from using PeekingDuck in our industry projects. For example, we recently had a human pose estimation project with Genesis Gym to provide feedback for exercises such as bicep curls. And we found that using PeekingDuck really shortened our development time. We are open sourcing PeekingDuck so that you, the computer vision community, are able to benefit as well. Over to you, Rizal, for the Q&A. Thank you.
Hey, hi, Liping. Thank you very much for the presentation. So let me just bring, the other speakers back on stage to address the questions. Okay, I'll be Alon, William, and Jonathan. All right, hi everyone. So yeah, welcome back. So for this last 10-15 minutes, we'll be addressing some of the questions that the audience might have. But let's begin with this first one, which is a standard across all presentations usually. Is a slide presentation going to be shared? So for the SGNLP team, who has slides to share just now, so I think we'll share the link to the description under the YouTube live page. Would that be right?
Yep, right.
Okay. Yeah. So whereas for the CV Hub team, Liping, I guess you didn't have any slides, so I guess the best way, for them to reiterate on whatever resources we have shared is of course the GitHub page.
Yep, that's right.
So, right. Thank you for that. Yeah, but we do have some questions, and I would like to throw this first question to the CV Hub team. So over here, this person that goes by the name of SG Eater, right? If I'm pronouncing that right, can you show the bounding box on live video while at the same time output the video to file? Yeah, so this is a parallel job thing. So is this possible?
Yeah, that's a good question. Yeah, so it's possible. You can just use the output.screen and the output.media writer notes both at the same time. I do this quite often as well.
Right, there you go. All right, that's the answer. So then perhaps I'll throw out a question of my own. As the main resource that you have shared today, which is the GitHub page for PeekingDuck, and of course, I think it will be of vested interest for your team, for people out there to contribute to your repository. So perhaps what if anyone is enthusiastic about contributing to your project, what are the first few things that they can look into to perhaps contribute to your GitHub repository for PeekingDuck?
Oh, that's a good question. Okay, I think the first thing you can contribute is to try to run it and see if you like it. And if you run into issues, you can either create an issue on GitHub or discuss in our discussion forum on GitHub or AI Singapore community page. And yeah, so that's the first thing you can help with, to basically find any bugs and try to stem them out. And another thing also that I think the community can really help is I talked about custom notes, right? So I think the ability of PeekingDuck to let people create custom notes, basically it just lends itself to a lot of imagination and creativity, right? So you may want to create for your own project some custom notes to do a certain task, like I can't think of any for now, but let's say you do it and it's quite nice. So what we actually encourage you to do is we have provided links for you to actually share your custom notes code either on the discussion board or the community forum, and you can share it, and you can tell people how what this node is for and why you created it, and if people find it useful and they like it, then they can also use it as well. And as I said, we're also trying to increase the number of nodes, useful nodes over time, right? So if we also start taking notice of the nodes you've created, and if we find that it's a feature that we don't have, but we would like to have, then we will contact you and we can work together to make it a real node in our PeekingDuck package. Yeah.
Yeah, perhaps the SGNLP team would like to, perhaps answer the same question if they would like to, in a sense, contribute also to the efforts of, this NLP community within SG. How would they do so? Because I see from the SGNLP page, within each of the model cards, there are links to the public GitHub repositories and even the research papers. So yeah, perhaps what's the best way for SG and NLP practitioners all around to contribute to the project that you are doing?
Yeah, thank you, Raisa. I'll take this one. Yes, so we highly encourage the community to engage, and we want people to be involved. At this point, people can use the platform and give us feedback. That will be very helpful. But in the very near future, we plan also to move to the second stage of having people contribute to the platform. And for that, we'll open up workshops that will explain how exactly to contribute. And we plan to add that section also to the documentation for people. So look out for that. We'll also announce that when that happens and make one of this workshop live for people to join. And the idea would be that if there's a research group or even individuals that have developed models that they think can benefit the community, we are open to host those models. And as John mentioned, a lot of the work we did was to create a unified API and easy to use for all the models that we've implemented and uploaded to our website. So the work that we would be happy to collaborate with researchers and practitioners is to implement that API or for their model that they wish to share with the community, and then we can host it on our website under one of the existing categories or maybe a new category if you have something exciting to share.
All right. Thank you for the answer, Alan. And there's, I guess, again, another question that popped up for the SGNLP team by Zeki Wong. For the SGNLP package, how easy it is to perform fine-tuning or additional training of the base models provided with our own data?
Yeah, I can take this question. So so firstly, we have written the preprocessors for like the data sets that the paper used to train the models. So if you are training on those data sets, it will be quite simple because all the functions and are written and the training function is there as well. But if you are using your own data and it's not in the exact same format, you might need to write your own preprocessor for it. So that will take additional effort, and usually, it might not be so straightforward.
Just to add to that, because some of the models, the way they were built, require a specific form of structure for the data that they take as input. So the idea for this preprocessor is just matched. If your data comes in that form, then you wouldn't have to work hard. But the preprocessor, what it does is just adapt to the structure that the model was built to take in.
All right. Thank you both, John and Alan. And I guess we're coming to the end of the session, but of course, before that, we can answer one last question by Lauren. All right, and perhaps William can take this. What are some upcoming releases by AI Singapore's Makerspace?
Yeah, I assume that's not Maker Studio. Yeah, it's Makerspace. Yeah, I think. Thank you, Lauren. And Rizal, as Alan mentioned before, right? Specifically for the NLP team, we have an upcoming release of some NLP packages that are designed primarily for languages of Southeast Asia. So we are currently working very hard with our regional partners to sort of like plug this gap. The fact that many of the Southeast Asian languages are of low resource in nature, as compared to the high resource languages like English and Chinese. So stay tuned. Hopefully, you will hear from us sometime towards the end of the year.
Right, great. Looking forward to it. I guess to keep in touch, all right, and to be involved in the discussion, do head over to all the links that they have shared, and especially their community page, which goes by the URL community.aisingapore.org. Right. The slides that they have shared will be the links to the slides. All right, will be shared both on DataScience SG's Facebook page and the Google Space SG's YouTube description, which you are viewing this video from, most probably. With that, on the dot 9:15, that's all the time we have for today. I would like to thank my friends here from AI Singapore very much for this very fruitful presentation, and we are looking forward to more products from you all. Okay, with that, any last words from anyone?
No, thank you for having us, Raisa. Yeah.
Okay,
thank you everyone for attending this session, and thank you, Raisa.
All right, thank you, Jessin, too. She's in the backstage right now. And with that, all right, goodbye to all. Have a good evening, and Tjhi. Bye, everyone.
Bye-bye.